Welcome to this explainer. It kind of feels like we're literally watching science fiction bleed into reality right now. For decades, artificial intelligence has basically been this ghost in the machine, right? Just floating in the cloud, generating text, or analyzing data. But right this second, four massive technological breakthroughs are colliding to give that digital ghost a permanent physical body. So let's piece together the anatomy of an autonomous future.
Here is our roadmap for today. We're going to cover the rise of physical AI, powering the autonomous future, robotics in deep space, and finally, assessing the existential risk.
All right, let's jump straight into part one, the rise of physical AI.
Looking ahead to the robotics trends for 2026, the sheer scale of this is absolutely wild. We aren't just talking about a couple of experimental robots anymore. We're talking about entire countries setting national targets for the mass production of humanoids and massive global corporations actively integrating them right onto the factory floor. We're also seeing robotics get totally democratized through RAS, that's Robots as a Service, which actually puts collaborative robots, or cobots, right into the hands of small businesses. But honestly, my absolute favorite part, the rise of the robotic night shift. Just imagine human workers setting things up at 5 p.m., completely turning off the lights, and just letting the machines run autonomously in a pitch-black factory all night long.
And this isn't just about a dumb robotic arm blindly repeating the same motion over and over. Enter agentic AI. This is a real game changer because it transforms a factory into a thinking, self-regulating nervous system. These smart systems actually reason, plan, and act. If a supply chain hiccups, the system realizes it, plans a workaround, and physically adjusts the factory floor entirely on its own to compensate. The whole ecosystem basically becomes one giant autonomous body.
Which brings us to part two, powering the autonomous future.
See, there's been a huge engineering bottleneck. To have completely untethered humanoids roaming around, you need an absurd amount of safe, long-lasting power. For years, solid-state batteries were the holy grail for this. They use hard ceramic instead of highly flammable liquid electrolytes, meaning they can safely store way more energy. But they had a fatal flaw. As they charge, these microscopic metallic roots called dendrites grow from the lithium metal and literally pierce the hard ceramic, short-circuiting the battery. And this created a wild mystery that completely baffled scientists. How on earth can soft lithium metal, which literally has the consistency of a gummy bear, crack right through stiff, rock-hard ceramic?
Researchers at the Max Planck Institute basically had two main guesses for this. Hypothesis 1, internal pressure was somehow building up and forcing mechanical cracks. Or Hypothesis 2, it was some sort of complex chemical reaction causing electron leaks. To actually figure this out, they had to freeze these materials in a strict cryogenic vacuum. They had to do this just to look at them without oxygen or water or even the electron beams of their own microscopes ruining the entire experiment.
Well, Dr. Yui Zhang and her team figured it out, and the answer is brilliant. They discovered there was no strange chemical buildup happening at all. Actually, scratch that. It's more like a mechanical attack. The lithium acts exactly like a microscopic, highly pressurized water jet. So even though the metal is soft and squishy, that relentless continuous hydrostatic pressure is enough to shatter the hard ceramic rock. Mystery solved.
So why does this matter to us? Well, because by finally understanding this pressure, engineers can actually fix the problem. They can design tougher ceramics now, or even intentionally build microscopic voids to steer those dendrites completely away from vulnerable areas. Overnight, we're suddenly looking at a real pathway to electric vehicles with triple the range, phones that last for days, and most importantly for our topic, the immense, stable power needed for our future untethered autonomous machines.
All right, moving on to part three, robotics in deep space.
So we have the physical bodies, and we're unlocking the energy to run them. But where are they going? Well, let's be real, space is fundamentally hostile to human biology. The extreme temperatures, the massive radiation, microgravity, it all makes our presence incredibly dangerous and super resource intensive. That's exactly why autonomous rovers like NASA's Perseverance on Mars or orbital systems like the Canadarm on the ISS are already out there doing the heavy lifting. They're handling the surveys and repairs that are just too risky for astronauts. But here's the catch. When we start looking deeper into the solar system, like to the outer planets or building sustainable colonies on Mars, we hit a literal speed of light bottleneck. Massive communication delays. You simply cannot joystick a robot on Mars from a desk in Houston in real time. It just doesn't work. Future exploration absolutely requires AI to be the autonomous architects of these worlds. They have to make complex survival and navigational decisions entirely on their own, without us constantly holding their hands.
And this lays out a really clear, logical roadmap for space colonization. Think of it like this. Step 1. Autonomous robots arrive first to safely survey the harsh terrain and gather data. Step 2. AI-driven machines start mining resources and actually construct the physical habitats. And finally, Step 3. Only after the groundwork is completely finished do fragile human astronauts arrive to a fully functioning, sustainable colony. Robots are basically our vital cosmic vanguard. And that leads us to our fourth and final chapter, assessing the existential risk. We are giving highly capable autonomous beings immense power and literally sending them to build civilizations on other planets. Naturally, we have to look in the mirror and ask some tough questions. Let's ground this right here on Earth first. A 2025 Stanford study uncovered a pretty wild statistic. They found a 13% relative employment decline for early career workers in the occupations most exposed to AI, and that's just since the widespread adoption of generative AI kicked off in late 2022.
But actually, hold on, before you hit the panic button, that 13% doesn't mean this guy is falling on the global economy. The same data shows that overall employment has actually continued to grow robustly. What we're really seeing is the displacement of routine, repeatable work. The workforce is actively shifting to leverage these white-collar machines to augment and boost what we can do, rather than trying to compete directly against them on mundane tasks.
Beyond the everyday economics, though, lies the ultimate existential debate, and it's one championed by some incredibly brilliant minds. The late physicist Stephen Hawking famously warned that an AI surpassing human intelligence could spiral completely out of our control. He theorized it could literally spell the end of the human race by outsmarting financial markets, human leaders, and our own researchers at every single turn.
Then again, on the complete flip side, you have leading AI pioneers who think this kind of dread is entirely misplaced. I love how AI researcher Andrew Ng puts it. He says worrying about an AI takeover right now is like worrying about overpopulation on Mars when we haven't even set foot on the planet yet. It's a fantastic reminder of how theoretical and speculative this fear actually might be.
So it really boils down to two distinct views. On one hand, you have the risk model, which is famous for the paperclip maximizer thought experiment. The idea is that a superintelligent AI doesn't need to be evil to destroy us. It just needs a singular goal. If you tell it to make paperclips, it might just harvest the entire Earth's resources to maximize paperclip production, wiping us out simply so we can't switch it off. But the reality check from experts like Jan LeCun is that AI has zero biological or evolutionary drive for dominance, self-preservation, or power. It's not a predator out in the wild. It's just an extraordinarily capable, completely unstoppable tool that we are using to expand our own horizons.
And that kind of wraps up our anatomical journey for today. From the birth of physical agentic bodies, to those microscopic gummy bear battles inside our batteries, all the way out to deep space colonization. It leaves us with a pretty massive question to chew on. As we forge these incredible autonomous machines to build our factories and explore the stars, are we simply creating the greatest tools humanity has ever known, or are we actively building our eventual successors? Thanks so much for joining me on this explainer. Keep asking those big questions, and I'll catch you next time.